All right, ladies and gentlemen, we just reviewed a little bit about what it is that we're doing in chapter three, and I asked you to kind of reconsider your notes, revisit them, and think about why are we talking about dilation? Why is that the main transformation that we're discussing in chapter three? That's because we're going to deal with similar triangles. So the green triangle is similar to the blue triangle if the scale factor between this side and this side stays the same as this side to this side. All the corresponding sides have the same ratio. And that ratio that we're talking about is the scale factor right over here. So let's make sure that we caught that scale factor is super important. And K in the problems represent the scale factor, right? So what I want to do is a couple more problems with you from today's assignment and see if we can figure out, what's going on, what are some of the key concepts, and just kind of solidify some of our understanding. So I took problem number one, I made it a little bit larger. Let's go take a look at that. Here's problem number one. And it's asking us to figure out, what's the coordinate rule or what is the scale factor? Okay, so when I graph that on Desmos, because I thought, let's investigate it on Desmos. Let's take a look. Not Desmos, GeoGebra, excuse me. I put the points down for P, J, K. And then what I want to do is I want to do a dilation on those guys. And I found it easier to choose polygon, right? So like, I think if I undo this here a little bit, I did some centering. Let's see. Okay, so I connected the points together. And when I start doing the transformation down here, the dilation transformation, it seems a little bit more difficult to do this transformation right here if I don't have a polygon. So let's do that real quick. And you just choose the 3 points that your polygon is made up. You notice how after I got to my third point, I had to go back to the original point that I started at. And then I'm going to scroll down here and I'm going to choose dilate. And then I'm going to choose the object I'm dilating. So now I can just click inside the triangle, right? And then I'm going to choose the point that I want to dilate around. And I'm going to do a scale factor of 2, okay? And you might say, well, where the heck did you see that scale factor of 2? Well, let me move point C. Oops, I got to choose the move tool. Move point C around, and let's just investigate this for a second, okay? So let me zoom out. If I move C to the origin, hopefully it doesn't get stuck on the origin. I don't think it will. But I'm going over 3 and I'm going up 2 to get to P. Notice to get to P prime, I'm going over 6 and I'm going up 4. So the amount that I went over and up on each one, let's just label it so we can see that, show the value. And then I go over here and I show the value here. You can see that 3 times 2 is 6, 2 times 2 is 4. But I know what you might be saying. Well, Nelson, that's not what it said in problem number 1. You don't have this bigger triangle, P prime, J prime, K prime over here. It's like it's right on top of the triangle. How could I get it to be right on top of the original triangle? So here's the original triangle. Here's the image. And they put those little prime symbols on the image, right? So that's how we can identify this is the new figure, the one that's in black, and then the gray one, I guess you can't see the other two sides because the black figure is sitting on top of the gray one. Anyways, so let's look back at GeoGebra for a second, and let's modify where the C is located until we get the triangles on top of each other. And you notice how GeoGebra uses the same notation, P prime, J prime, K prime, right? So these are the image points, and this is the pre-image, or they call it the original figure. So I move this point. Oh, look at this. If the center of dilation is P, then P prime and P are right on top of each other. And then, oh, look at this. J prime is out here. That looks exactly like what we had back on our homework problem. So I was going from the center of dilation, I was going over 1 and I was going up 2. Now I'm going over 2 and I'm going up 4. So the scale factor is 2, right? The scale factor is 2 here because I could see that, the amount that I was going over and up is doubling. So I went over 1 up 2. I'm going over 2 up 4. I hope I'm making that clear. Um, if you need some help, you're going to call me over, right? Hey, we're going to look at another one. So here's question 4. They want us to, on a separate sheet of paper, graph these points. Okay, so let's do that real quick here. I'm going to go -10. Let's say -10 is like out here. There's -10. And then I'm going to go to +4. So let's say 4 is like right there. Okay. Remember how the X is the first number and the Y is the second number. So it does say, on a separate sheet of paper. So on your homework piece of paper, wherever you're doing your work, where you got your notes, all that kind of stuff, let's just practice graphing some of these, by hand. If I go to like -4 here, let's say that's where -4 is. I'm trying to do this with my mouse instead of turning my pen on. And I go up to 4 here. Oh, that's nice. It's horizontal. See, it's nice and horizontal here. I could just connect it with a line. I don't know how accurate it's going to look, but ooh, I don't want an arrow on it, right? Because that would be a ray. Shoot, let me undo that real quick, and let's just connect it with a segment. Okay, so here's my one segment, and then -4, -8. So if I go -4, you got to be really careful here, don't you? I mean, if you go in the wrong direction, it's not going to work out for you. So -8 down here. Hopefully, I don't know if that's twice the length here. Ooh, I don't like that. Let's see if I can move this down a little bit, kind of off the line, I guess. And here, oh, my 8 is in different pieces. That's kind of weird. So let's put a dot right down there, right? So -4, -8 is right here. And then let's connect them with the lines. Okay, so here we go. Oh, geez, that should be vertical. Come on, get over there. I'm going to adjust it here. Let's make it vertical. All right. And then my other one's going to go from here. Come on, line from here. Why is it not doing it? I want that line right there. Come on. And I'm going to go from here, there it goes, to here. Okay. So it says we have a 0.25 scale factor. There's my scale factor right there, scale factor. So instead of going over, 10 and up 4, I'm going to take a quarter of that or a fourth of that, okay, or divide it by 4. There's a lot of different ways to think about 0.25. I like thinking about it as 1/4, probably better than 0.25. Because I can think about like 10, I know I'm dropping the negative for a second, but 10 divided by 4, how many times will 4 go into 10, right? That's kind of what we're doing when we multiply by 1/4. We're dividing by 4. So it goes in there 2 times, right? So that's 8. And then there's a remainder of 2. And so what is how many times will 4 go into 2? Well, that's a half. So I've got 2.5 if I convert it back to a decimal, right? Because the decimal point is here. You could put a 0 there. You could drop your 0 down here, and you could say how many times does 4 go into 20, if you will, and it goes in there 5 times. But now you're on the right side of the decimal. A lot of different ways to think about this. You could just plug it in a calculator. That's what the scale factor is going to do. It's going to multiply both those numbers by 0.25. Now, the key is, though, that the center of dilation is the origin. It's that easy if it's the origin. If it's not the origin, then you got to figure out where your center of dilation is and figure out, like, to get to this point, I went back 2 and I went up to, no, excuse me, I went back 1 and I went up 2. So then to get to the corresponding point, I'm going to go back twice as much and up twice as much. So it's more complicated when the center is not the dilation, or when the center of dilation is not the origin. All right, so what do I got? I got -2.5, right? -2.5. That's what we said the 10 is multiplied by 1/4, right? And it's got a negative on it. And then a fourth of 4, well, that's easy. That's 1. How many times will 4 go into 4? 1 time. So my new coordinate is -2.54. Now I want to test it out. -10, 4. So if I switch over here and I move one of these, well, first of all, let's move, if it'll let me, move the center of dilation to the origin. Now I'm going to move one of these points, one of my original figure points, to -10, 4. So let's move this guy over here to -10, 4. And let's see. Oh, wait, I got to change my dilation, my scale factor, right? Right now I've got a scale factor of 2. And I want a scale factor of 1/4. So let's see if I can delete this guy. So let's delete this figure right here and delete this and this and this. And let's do a new dilation. So I come down here and I'm going to go to dilation. Where did it go? Transform. There it is right there. and I want to choose this object. I want to choose this as my center, but I want to do a scale factor of 1/4. Okay. And now let's see if J prime is at the correct spot here. Cancel. I know what the problem was here. Hold on one sec here. I've got my dilation deal set up right now, and I need to have my select tool. There we go. There we go. I couldn't get the label to show up. All right. So, oh my goodness, 0.75, 0.5, 0.75, 0.5. That's not right. I want that point right there. Where's that? Oh, it's right there. Just couldn't see it. Negative 2.51. Is that what we got? Negative 2.51. Yes, it is. Hey, I hope I'm making this clear, ladies and gentlemen. You're just going to call me over, say, hey, Nelson, I need some help. I'm going to be walking around helping you guys out. Thanks for watching my video.